All right, so this is 1B2. It's called graphing absolute value functions. So yesterday was just a quick introduction to like, what is an absolute value function? We know now that it's like a V shape whenever you see those absolute value bars. And we know that we talked a little bit about like what the numbers in front of the bars tell us to do, what the numbers inside of those bars tell you to do. That's kind of what the goal of yesterday was, just to kind of introduce it so that today we can really jump in and practice actually graphing these absolute value graphs. Okay, so the first quick warm up just to practice domain range. Some of the first few here though, these are not absolute value, but they are good practice of just kind of making sure you remember domain and range and whether something's a function. This was from unit 0. And remember the test eventually that's coming up is going to include unit 0 on it, just kind of a little bit of it, even though we only had a few days of it. Test is not till next week though. All right, so to decide if something is a function, we have to make, with the graphs, we do that vertical line test. So like you would draw any vertical line anywhere at all on this, and it would always hit just once. And that means, yes, it's a function. The domain and the range for every line that goes on forever in both directions, like it's not like a segment, but it's actually a line, would be negative to positive infinity. Same for the range, because you're going everywhere left to right and everywhere up and down. There's no kind of stops here. And then for the end behavior, we write this as x goes to, and we'll fill in, well, you can write first to the left, that means negative infinity. And then we'll fill in what happens to y as x goes to positive infinity. We'll see what happens to y. We may not do all of these warm-ups questions, but just to get an idea of like, we're bringing back domain and range today, but specifically with absolute value. So that's coming up. Okay, so as we look to the left, this graph is going down, the arrows point down. So this would be negative. And as we're going to the right, this graph is going up. So it's positive infinity. All right. That's it for that first one. If you look at the next one, it's just single dots. This one was the one that we called set notation. When you're just writing out the points in these like curly brackets, and you're just writing out like all the possible x values that go from least to greatest. So for here, we have -1, then you put a comma, then we have 1 at 1, then we have 2, and then there's 2 at 4. So 2, 4, and then there's one final one at 5. That's how you write it when it's set notation. We're not going to do that today with absolute value because all of those are not individual points like this, but we will have to remember how to do that for the test that's going to come up next week. Okay, so this is not a function this time because of this issue right here. There's 2 points that are sitting in a straight line, vertical line, and we can't pass the vertical line test this way. Okay, but the range, same idea, just look at the y values from least to greatest. So down here, this is sitting at -1, and this one here is also sitting at -1, so we'll count that 1 time. Then we have this point at 1. Then we have this one up here at, I know the points are a little bit not quite on there, but we're going to say it's at 4 instead of like dealing with any kind of decimals. And then the last one up here, and this one's also at 4. This last one here is 5. Okay, so that is how we would do set notation, which is what you do when you have individual points. All right, well, we're going to skip this last one. If you want to do that one just for some more practice, you can absolutely do it. This is called the square root function, and we're going to come back to it later on this year. All right, so let's get to the actual graphing. And it says here, we want to select, it says select values for x to help you graph each absolute value function. Check your tables with the technology. That means if you have either a graphing calculator or even a scientific calculator, you can use it to help you do some of the arithmetic. But eventually today, the goal is to be able to not always have to rely on a graphing calculator to be able to graph these. So we are going to try to use like even slope to help us. Because if you think about it, absolute value is made up of 2 lines. And so if we know how to graph a line, basically just graphing 2 lines together to form our V shape. But a table can be helpful so that you can, this is what we did yesterday as well, just to see kind of what the values will come out to. So let's try the first one using kind of filling in the table here. So we have our graph, either you can use a graphing calculator or even just one of these scientific calculators just to help you kind of do some of the arithmetic so you don't have to do it all in your head. And so we would write down this just to kind of have some work here. You're plugging in -4 inside of the bars because that's what X is, and then you're adding 1. Okay, so either use your calculator at this point or just do the arithmetic in your head. +4 is what I would get when I have those -4 in the bars. So +4 plus 1 would be a 5. And then technically we do this over and over again. Now it can get kind of repetitive, right? Writing it so many times. There's also a lot of points in this table. You don't always have to have as many to be able to graph out your V shape or absolute value graph. But this one is going to be 3 plus 1, which is 4. And it's going to keep doing that for a while until you get to the vertex, which you may not know when that's going to happen, but we'll learn more about how to identify the vertex. So this would be -2 plus or +2 plus 1, which is 3. And if you are using your graph, actually on these, I don't believe scientific calculators, I'm not sure where the absolute value button is on these. So I'm going to skip using that, but there is absolute value bars on these graphing calculators. And you just go to math, and then you go to the right arrow one time. And then you're putting those, it's that first option, the bars come up and you can put in whatever number, like -1, for example, plus 1, and you get 2. Okay, we're gonna keep going through this. I'll just tell you what the rest kind of come out to. You get to the next one, which is 0, 1. I'm gonna show you this one here now, because if I plug in a +1 and it stays positive, 1 plus 1 is actually 2 again. So it's jumping back to where it was originally. This is called, we're about to talk about symmetry, where it's like the same on one side as it is on the other. So then we keep going. You're probably going to have an idea of where this is going to go. It keeps going from kind of going backwards. There's 2 and 2, 3 and 3, 4 and 4, 5 and 5. That's that symmetry where it's the same on one side as it is on the other. And we want to circle where it had that flip, where it switches directions, and that's here. This is called the vertex. Okay, so as far as like how to go about graphing it, the first example we just did with tables, we don't always have to use tables. You can also use slope as you come up with these. So let's go ahead and go to the bottom here, and we're going to plot these points so we can see what our V graph looks like. All right, so at -4, you want to go up 5. At -3, you want to go up to 4. Then we have at -2, 3, -1, 2, 0, 1, 1, 2, 2, 3, and you're going back up until the end, 4 and 5. And there's my V graph, or my absolute value graph, that has been translated. We're going to talk about what this did exactly, but it moved up from usually sitting at 0, 0. It just kind of moved up one spot and moved everything up one spot. That's what this table told me. That's what this graph or this equation tells me to do. And we talked yesterday about like, what does that +1 do? Okay. So that works out pretty kind of nice that we were able to just kind of take that equation, figure out the X or figure out the Y values from the X values that were chosen. If a table is provided for you and the X values are not there, you can pick, a variety of negatives and positives, including where the vertex would be. This one here, we're going to do as well. It looks a little bit more complicated because it has a lot more numbers to it, right? But we can, again, either use the table to fill out and then to graph it, or I'll show you another method it feels simpler, feels quicker, because it uses this A value as like a slope, essentially. Okay, so what we have to do first, though, on this one, if you are going to use the table, is you're substituting in, again, the -4 like into X, and you keep doing that over and over again. If you have a graphing calculator, there's also using the Y equals button to graph, but we're not going to be doing that, just so that everyone that doesn't have a calculator doesn't feel like they have to have a way to do it. Okay, so this right here is what I want to either type into my calculator or figure out, kind of just adding everything up in my head. So I'll just use a calculator here, -2, then we need those absolute value bars, -4 plus 1, come out of the bars, and then a -3. So that is a lot to type out each time. So it comes out to -9. That's what goes in here. And then you would do the same thing for all the rest. And I know that can seem like a lot of like typing in. So feel free to just go back to the previous step. And if you want, you can just kind of change those numbers. And then that goes a little bit quickly. Okay, so -7, you're going to probably see what the pattern is in just a second here. Then it comes out to -5. And all I'm changing is the X value, which is that first number in the absolute value bars. Then we get -3. And then you're going to get 0 here for inside here. So this comes out to -5 again. It like bounces back, right? You can see that symmetry where it started getting to a point. This is called the vertex again, where it now jumps between these X value or Y values. So now you're going to go, you can probably see where it's going next. It's going to go -7, then it's going to go to -9. But if you're not sure, just rely on your calculator to check what those values will be. So then substitute 1 and notice that's where that -7 came in. And then you do the same thing for all the rest. Now beyond this, these last two, they're going to kind of keep going. You can probably notice it's going by twos, like it's being more -2. So it's going to go all the way till -13. Now these won't even fit on our graph actually, because we don't have as much room. But that's okay. As long as you have a few of these points that you can graph out so you can see what the graph looks like. Let's go ahead and do that for the bottom here. So I want to definitely plot as much as I can fit. I'm not sure if there's -9 won't 3, 4, 5, 6. Yeah, it won't fit. So let's start at -3, -7. So right at the bottom here at -3, that goes to -7. Then at -2, we're going to go to -5. That's 2 up. And then at -1, go to -3. At 0, we're going to -5 again, which is down here. And then at 1, you're going to -7 again. And that's where we'll stop with that because there's just not enough room to finish. Okay, so it's upside down, right? It flipped over. That's what the negative did. The 2 that was in front of, I'm going to move it up just for a second. That 2 right there, it tells me that it's going to make it narrower, like Mrs. Mar talked about stretching it out. It's a stretch, so it's made it narrower. And it moved the vertex from being at 0, 0 to this vertex here, which we were already circled was -1, -3. You can also write it in right here. And let's see where this vertex kind of comes from if I go back to my equation. If you notice, there's a 1 there and a -3 there. That's similar to what my vertex is. It's just this is a positive 1 and my vertex has a -1. So if you kind of see what's going to start happening is that to find the vertex, you're going to switch the sign of what's in the bars and then keep the Y value or the K value the same, the -3. Okay, so hopefully you get kind of the gist of it. This last one here, I'm going to show you kind of without the table, and then we'll do more on the next page with hopefully kind of seeing the same thing as well. So the first thing I want to do here is figure out what the vertex is. Okay, so the vertex, what we're going to do is we're going to switch what's the sign. So if this is a -1, we're going to actually write +1 and then use the same K value. The number at the end there is 2. So you're going to start at 1, 2 on my graph. So let's find 1, 2, and I put a point. All right, and then we look at, so we kind of dealt with the whole right-hand side part, everything that's included in the equation except the -1/2 so far. We did everything with that. So now it says -1/2. We're going to kind of treat that as a slope. And if you think about putting the negative either on top or the bottom, it doesn't matter which spot you put it. One way to move here would be to go down 1 and right 2, right? Think about slope and how we just do the top number is always the rise and the bottom number is always the run. So let's go ahead and go down 1 and right 2 and you put a dot. Go down 1, right 2, and you put another 1. And you could keep going until you run out of room, right? That goes till the end there. Now what you have to do is remember this was the vertex. It might help you just to put a little V for vertex because that's where you know that it's going to switch directions because this is not just linear. This is absolute value. So we know that it has to go in the other direction, but it has to follow the same slope. So still got to go down 1, except instead of going right 2, you're going to go left 2. So you're also going to go down 1, left 2. Okay, and you keep doing that for a few times until you get enough points to graph it out. And then you just connect both of these with straight lines so that you have your V shape. It happened to be upside down again because there was a negative, and it looks wider this time because of the 1/2. Anytime there's a fraction or a decimal that's between 0 and 1, you are going to have something called a vertical shrink. And it actually, when you shrink it down, it gets wider. Okay, so we didn't fill the whole table out here. You could have if you wanted to use like a computation here, or you can stick with just kind of going through that way. All right, and so we're just going to do some comparisons here, and then we'll practice graphing some more. On the next page, you can decide if you want to use slope or if you want to just do it using a calculator. And I highly recommend using a calculator. Don't try to do everything in your head. At the top here, it just kind of reminds you, this is like the general form of every single absolute value function. It starts with the bars that originally were there with just the x, and that was called the parent function. This is like a transformed function where the positive, or it could be positive or negative in the front. Remember, that tells you if there's a reflection. Okay, so that right there tells you reflection, or like whether it's flipping, that's another word for reflection. The A tells you if there's a stretch or a shrink. And then the H tells you how to move left or right, and it's always the opposite direction. Like if we see a minus sign, we know that means actually going to the right. And then K tells you move up or down. Okay, so I know there's a lot here. We may not do everything on this page, but let's at least pick a few to kind of go through. So the first, actually, if you notice, these are the same 3 graphs. And the whole point here was to see what you would do if you didn't use the table method like the front page, but these are the exact same 3 from the front. So let's look at the first 2 specifically and using the option that we just did on the last problem, which is first identify the vertex, your H and K. So if I notice here, there's nothing inside those absolute value bars, that's like 0. Okay, so far I have 0. And then I use the K value 1, right? So 0, 1. Looking at the number, if there's a number in front of the absolute value bars, that's A. There's no number there, so that's just 1. And then since it's positive, there's no negative in front of there, it's going to open up. Okay, so again, we're going to start with the vertex at 0, 1. That's right up on the y-axis, 1 spot up. And then look at the slope, which is 1, right? So the slope, if there's no number there, there's just like an invisible 1 there. And that means like if the slope is 1, I could write it like 1/1, where it's up 1 and right 1. So I want to go up 1, right 1, and put a dot, and keep doing that for a few times, or you could keep going until you run out of space. I would say about 3 or 4 spots is good. Same thing in the other direction. Remember, this graph has to open up. So make sure you're going up 1 and left 1 instead of trying to make it so that it opens down. We don't want it to flip. We want it to make sure it stays this way. Okay, and there is our graph. And if you compare it to the one on the front page, it's the exact same graph. It's just 2 different ways of finding the answer. You could either use a graph, use a table, or you can just do it with identifying the vertex and looking at what A is, because this is like your slope, essentially. Just be careful to call it an actual slope. It's kind of like, let me just put it in quotations, because remember, we're not just going, it's not linear. We're not just going in one direction. You have to make sure to get the other part to get your V to show up. And so then here's domain, range, and end behavior. Domain, it goes everywhere left and everywhere right. So you're going to find out pretty soon that every single absolute value function is going to have the same domain as long as it keeps extending out to the left and right. There's no, there should always be arrows there that tell you that's always going to be negative to positive infinity. The range, though, will be a little different. It'll either be the smallest value. So if the graph is opening up like this, the lowest this ever gets is 1. So it's going to be 1 and then comma infinity, because it goes up forever. And then we write our end behavior. As x goes to negative infinity, we want to see where does y go. And as x goes to positive infinity, we also want to see where y goes. So looking at those arrows for end behavior, they're both pointing up. So these are both going to be positive infinity. The nice thing here with all these absolute value graphs that you're going to be working on, they're always going to have the same end behavior, whether they're both positives or both negatives, because they won't go in opposite directions. They're just either both pointing up or both pointing down. So it tends to be easier. So number 2, this one here, we're going to just practice graphing it. And then I'm not going to do this one because we just did that on the front page because I chose not to do it with the table, just so we're not doing so many problems. But let's try this one because this one has everything going on. So let's see if we can do that together. So first, can I have a volunteer that wants to write down what is the vertex? Remember, you got to switch that sign. Yeah, what do you think, Shauna? Okay, close. This one, you got to switch the sign of +1. So that would be -1. Yep. And then you said -3, right? You got it. So that's our vertex. Looking at the A value, it's the number in front. What's my A? -2. Thanks, Corinne. And then it has to open down because of that negative. As soon as you see that negative there in front of the equation, it tells you to open down. Okay, so let's always start with the vertex. You want to plot this point. -1, -3. Okay, there it is down there. But remember, the graph is opening down, so you already have like a visual idea of what it's gonna look like. It's gonna go down like this, sort of. And so I just need to use my slope to help me get there, or my A value to help me get there. So if it helps you to write your A value as a fraction, if it's just like a number like -2, feel free to put 1 on the bottom of it, because this is like saying down to right 1. But not only is it going to go right 1, it will also go down to left 1 when you get the other direction, but at least start with one direction. So down to right 1, down to right 1, we get 3 points right there. That's it. Do the same thing in the other direction, down to left 1, down to left 1. And this graph is the same as the one on the previous page. Okay, and then it's domain and range again. Domain is still all real numbers. If you don't want to use this inequality notation, you can use that symbol for all real numbers, which was like that capital R with that extra line, or you can write out the words all real numbers if you'd rather do that. The range, it sits up at 3, is the highest point it ever gets. So this range is going to look a little different now. It's going to start with -infinity because it's going down forever, but then it'll stop once it gets to -3. And then you'll put a bracket. So the range gets its Y value, the number, whatever the number is. If you notice, this one's a 1, this one's a -3. It comes from that K value, the last number there. So like if I was to do the domain and range on this one, it would have a 2 in it, depending on if it's opening up or down. You can see what the difference is between the two. And then for end behavior, like I said, they're both either going to point down or both point up. These are both pointing down. So they're both -infinity. Okay, so we write that as x goes to -infinity, y arrow -infinity, or that just means y goes to -infinity because the arrows are pointing down. Same idea for this one. As x goes to +infinity, y goes to -infinity. And again, if you want more practice of figuring out domain, range, and behavior, you can do this one from the front page. It probably helps to look at the graph to do it though. Don't try to do it without. But the domain is the same. Range will have this 2 in it. You have to decide if it's going to be -infinity to 2 or the other way around. And then end behavior will be, again, the same as this because it's upside down. This is opening down. Okay, so if you wanted to fill anything out there, you could. But let's just finish up the bottom here. We're not going to do all of this, but hopefully just to get a start here, and then you could get some time for homework as well. It says identify the vertex and a value from each table. So sometimes you'll be given a table and you'll just have to identify some key information from it. It does help to graph it out, but you don't always have to do an actual graph. I'll show you the graph on these just so that it helps answer some of these questions though. So for number 7, we're going to graph -4 and +3, and then -3, +1. So it's kind of going every 2. You can kind of see what the slope is as you're graphing this out. -1, -3, 0, -5. And then it's going to flip here and get to 1, -3, And then the rest of these are going to be symmetrical. Okay, so it goes all the way to 3, 1 like that. So you don't have to always graph it if you're given a table, but it is helpful to see what that graph looks like. All right, and now we can kind of answer these questions about it. So I'm going to circle the vertex like we've kind of done all along. So if I look at some of the y values, you're looking for where did it have the switch, where it switches, like where it surrounds itself with the same number, and that's right here at 0, -5. So there's my vertex. The a value, the only way to figure that out is by, well, there's 2 ways to figure it out, but it's by using the table or the graph. It's kind of easier with the graph though, because we can just do look for the slope, like you're going up 2 and right 1. So the slope or the a value is technically 2. Here's how we can also find it. You look for the patterns between the y values of the table and the x values. So from 3 to 1, I'm going down 1, or I'm sorry, I'm subtracting 2 each time. So I start by subtracting 2 up until I get to this point where the vertex is, but then I start adding 2. Okay, and I add 2 until the very end of that. But then when I look at my x values, they just keep adding 1 the whole way down, +1, +1, all the way, never switches, because you're just starting at the negatives and going all the way to the positives. Okay, so that would keep happening all the way through. So what you have to know is when you do absolute value with the table, and like, let's say you don't have a graph handy, then you have to actually look for like whatever the sign is of the second pattern that you found. So like, notice this is positive. That's why the a value is positive. Whereas these are negative, you have to either like switch the sign of the first one you see or come further down past the vertex, and that's the sign that's going to be the a value. Or if you do have a graph handy, just kind of look at the slope up to right 1, and that's what keeps happening. Or the graph is opening up. That's why we know it's a positive here instead of a negative. So that's why the graph opens up. Okay, and then we would do the same thing for number 8. I'm not going to graph this one out. Let's just use the table and see if we can come up with the answers here. So looking at the pattern, we are adding 4 every single time so far until we get to 0, and then we start subtracting 4 till the very end. Okay, and so when I find that vertex, it's where it switches between, it kind of surrounds itself with the -4s here, because that's what's the same on both sides. There's only going to be one vertex that looks different from all those other points. So this is -1, 0. Okay, the a value here is going to use that 4 that I just wrote down, but to decide if it's positive or negative, you always either take the second sign, so that's these negatives, or you switch the first one. So this is going to be a -4, which means it's opening down. All right, and then finally, it just says table of absolute value functions must be symmetric. There's 2 words we write here. Symmetric just means that the same exact value, like you're going to see a repeated values on both sides of the vertex. So the same y values repeat on both sides of vertex. So you can always figure out if a table is absolute value by looking for symmetry. Okay, and then the second thing is it kind of reminds us of linear, or that the rate of change is constant. So rate of change just means like slope. It has to be positive then negative, or so is positive then negative, or negative then positive. That's kind of what we saw in both our questions here on number 7 and 8. The first one went negative first, then positive, and it has to be the exact same number every single time. All right, and that's where we stop. If you have any questions, let us